Finally, we can also derive one more equation from this equation and this equation that we have derived right now. We have average velocity equal to half of final velocity plus initial velocity, and from here we have change in the position of the particle is half of v plus ut. Now what we will do is we will modify this equation and eliminate this initial velocity, and by getting this u value, then we can substitute in this expression here to get the final expression. Okay, so we can modify like this. We can get 2x minus x naught equal to vt plus ut, and make ut as the subjective formula. We'll get 2x minus x naught minus vt. Okay, now from here we can substitute this in this equation, the one that we have derived, that is x minus x naught ut plus half at square. So substituting this value of ut from here, we will get x minus x naught equals to 2 times x minus x naught minus vt plus half at squared. And further simplifying this, we will get by grouping the like term minus x naught equals to minus vt plus half at squared. And after multiplying this by negative in whole of the equation, we will finally get positive x minus x naught equals to vt minus half of a t square. So this is the final equation that we are getting, because see here we have negative, so negative will be positive and negative positive will get negative. Okay, now let us see the pattern of the equations that we have derived. Okay, pattern of equations, so that we will understand why we have derived so many equations. So the whole equation, and number one equation that we have derived is v equal to u plus at. Number two, x minus x naught equals to ut plus half of at square. Number three, we derived 2ax minus x naught equals to v squared minus u squared. And number four, we have derived x minus x naught equals to half of v plus u t. And number five, the last equation that we have derived is x minus x naught equal to vt minus half of a t squared. From here, what are the missing values? If you try to see this equation very carefully, you can see that none of the equation has all the terms like initial velocity, final velocity, position of the particle, and acceleration term. Okay, so if you see this equation, you will see that the missing value is the particle position, x value is missing. And if you see this, you can see that the missing value is v, final velocity. And if you see this, the missing value is t, the time. And if you see this, the missing value is a, there is no acceleration. Okay, and if you see this, the missing value is u. So from this, what we can say is, depending upon the question, whether all these parameters are given or not, some will be given, some will be not given. So based upon the question, whether any collective parameter is given or not, you have to use the correct formula to solve the problem. That's why we have derived a lot of equations, but each equation having some missing values. For example, if you use this formula, then we cannot calculate this x. Similarly, v from this formula, t from this formula, a from this formula, and u from this formula. In next video, I will discuss about how we can use this equation in the real problem. Like there will be many cases, and in special cases sometimes we have to modify these equations, okay, like in the straight line, and sometimes straight line but under the influence of gravity, and depending upon whether it has initial velocity or final velocity, equations will change. So I will discuss this in detail in next video. I hope you have enjoyed the video and you have enjoyed the derivation. See you in next video. Thank you.